Hello and welcome to my home gym. It's the only place in my house that has a whiteboard. We'll need our whiteboard for our lesson today. We're going to be talking today about opposites. So when you're thinking of opposites, what are some things you think of? We'll think math, okay? Any ideas? Math? Yes, you have addition, subtraction. So we have addition, we have subtraction. Any others? Multiplication, division. How about in life? Anything in life you guys can think of that, oh yes, pushing and pulling. Those are some good ones. We could even talk about forward, and we could talk about backwards as well. Good and evil. That's going to be hard to tie into this lesson, but it is a very good opposite, that's for sure. All right, so we want to talk about opposites, and I think often when people think opposites, they think that it's two opposing forces, whereas it's more, I wish you could think of it maybe as like two sides of the same coin. So they're actually two forces that are trying to accomplish the same thing. For instance, if I'm talking about forward or backwards, if I'm walking forwards, that is the same, if I was going this way, forwards, would be the same as if I was walking backwards in that direction. We're doing a different motion, but we're trying to accomplish the same thing. Same with push and pull. So if I try to push an object, it's the same as trying to pull that object. When we talk about addition and subtraction, so for instance, if I have 5 plus 4, that can be the same as 5 minus a negative 4. So when we're talking addition and subtraction, they can be two things of the same coin. So the same goes with multiplication and division. We talked a little bit about reciprocals. So for instance, the reciprocal of 2 is 0.5, 0.5. So I could say, if I had the number 4, I could go 4 divided by 2, or I could say 4 times 0.5. So they're both actually trying to accomplish the exact same thing, and they're both going to equal 2. So when we're talking about multiplying and dividing fractions, we're actually going to do the same thing. We're going to stick with our multiplication, with our multiplication and division, and we're going to go over that in this class, how we're going to do that. So again, we're going to just go over your previous lesson that we talked about reciprocals, where we talked about 2 and the reciprocal is 0.5. So those multiplied together will equal 1. So your reciprocal will always equal 1. So we're going to draw that in a fraction, because 0.5 in a fraction, 0.5 is going to equal to, any ideas? Half? Yes, half. 0.5 equals half. So we're gonna start using fractions instead of using decimals now when we're talking about reciprocals. So to prove 2 times a half, so 2 times its reciprocal. So if I have 2, so if I have a half, I'm going to go a half times 2. I'm going to draw that on the board. I've got a half. And if I have 2 halves, so a half times 2, I'm going to end up with a whole. 1 whole. Okay? And the same goes for, if I switch around, I can switch around my equation and say, I can say 2 times 1/2. So I have two items, and if I take half of that, so half of the 2, I'll erase 1, get rid of 1, and what I'm left with is my 1. So when we're talking multiplication with fractions, we actually want to take this number, multiply it by that number. So we want to be able to explain that. So looking at the number 2 as well, when we're talking reciprocals, we can say 2 over 1 is equal to 2. So we can write our whole number as a number over 1. So when we're talking very simple math, when we're talking fractions, I can go 2 over 1 times 1 over 2. So 2 times 1/2 is equal to, and what you do with multiplication is you multiply top to top, bottom to bottom, and I would get 2 over 2, which is equal to 1 over 1, which is equal to 1. So that's multiplying fractions in the very basic of forms. So we are going to use a couple different, we're going to use a quarter, and we're going to use 2 as our main numbers when we're talking about multiplication and division. So if I said 1/4 times 2, I would get, so if I have a quarter of a circle here and a quarter of a circle here, that, in the grand scheme of things, I have my whole circle, I've got 1 here and 2. And that's going to equal 1/2. If I take away these lines, I'm going to get 1/2. So I know that 1/4 times 2, 2 quarters, is going to equal 1/2. Okay? So if I take it the opposite way, and I say 2 times 1/4 equals 1/2. So I take 2. So if I have 2 wholes, and I take a quarter, so I need 4 to make a quarters. So I'm going to go in half. I'm going to put these in half. And I need a quarter of this. So if 1, 2, 3, 4, I only need 1. If I shade in only 1 of that 2, or 1/2 of the 2 items, I have 1/2. So 2 times a quarter is equal to 1/2. We're going to put that into numbers now. When we do our numbers, 2, remember 2 can be 2 over 1 as a whole number, times 1/4 equals, we're going to take our top by top, bottom by bottom, and I get 2 quarters, which equals 1/2. So again, if I do the opposite way, it's going to be the same thing. If I do a quarter times 2 over 1, I'm going to get 1/2. So we're going to switch to division. So we've got multiplications pretty simple. Top times top, bottom times bottom. We are going to switch to division. I've got 1/4 divided by 2. So 1/4 divided by 2. So if I take my quarter, I'm going to take a quarter section of a circle, and if I take that quarter section and I divide it by 2, I get this much here. So in the whole circle, I divide that, I need to divide here and here. I'm going to have 1, 2, 3, 4, 5, 6, 7, 8 parts, and I'm going to have one of those. So I know 1/4 time divided by 2 is going to equal 1/8. So I can so what we do when we divide what we do when we divide to get that eighth on the bottom, you can see that 4, I know that 4 times 2 is going to equal 8. So what we're going to do is we're going to take this number, this 2 over 1, still equals 2, and we're going to flip them. We're going to flip them around when I divide and make it a multiplication. So it will become 1/4 times, as they flip over, it'll be 1/2. And I equal, so top to top, bottom to bottom, multiplied, I get 1/8. So we did a visual proof of that, and this is how we multiply fractions, or divide fractions. So sticking with our same numbers, we're going to go 2 divided by 1/4. Now, the easiest way to kind of understand this in division is I'm actually going to go a little bit off the board, and I'm going to talk about 9 divided by 3. So very simple, we all know 9 divided by 3 equals 3. So another way to ask yourself is, when you're doing division, is how many times does 3 go into 9? So it goes in 3 times. 3, 6, 9. So it will go, 3 goes into 9 3 times. So when we're talking 1/4, we can ask, how many times does 1/4 go into 2? So we're going to draw and visualize that. So if I have 2, and if I have my 1/4 here, 1/4 here, how many times will this 1/4 go into 2? So I'm going to divide my 2 into quarters, and I can see that it's going to go 1, 2, 3, 4, 5, 6, 7, 8. So we know that the answer is going to be 8. Or we know that a whole number is 8 over 1. That is correct. 8 over 1. So it's very important when we are doing division that we need to know the order, because a quarter divided by 2 was 1/8, but 2 divided by a quarter is 8. So when you're doing multiplication, it doesn't matter which side you're on, but when you're doing division, it matters what the order is. So we're going to do this as a fraction. So I know 2 over 1. So 2 over 1. So I'm going to take that division and I'm going to flip it around and become a multiplication. So times 4 over 1 equals 8 over 1, which 8 over 1 is equal to 8. So 2 divided by 1/4 equals 8. All right, we are going to do one more thing. So what happens if I'm multiplying fractions and I have a mixed fraction? So what if I have 2 3/4 times 3/4? 3/4. So 2 3/4 times 3/4. What the easiest way to do is I want to make this into a fraction. So I take my 4 times my 2 and I would get my 8. 8/4 plus my 3, so I get 11/4 times 3/4. So do you see how I did that? So 4 times 2 becomes 8, plus my 3 becomes 11 times 3/4. So I know that this is going to equal 33/16. So right, I multiply top by top, bottom by bottom. And then I can actually take out this and become 2/16. So 1/16 is 16, 2/16 is 32, so I could say 2 1/16. So I know 2 3/4 times 3/4 is equal to 2 1/16. All right, we're going to do some other practice. So make sure you have your pens out, pencils, and paper. And I'm going to write a few practice on the board. Actually, no, I'm not. I'm going to do dividing first. So same thing, if I go dividing, I want to make this into a compound. I'm going to make this into a compound, not a compound, a fraction that's improper, but we're going to make it into just a complete fraction. So again, I know that that is going to become 11/4 divided by 3/4, so I'm going to flip it around. So I get times 4/3. So I know that 2 3/4 divided by 3/4 is going to give me 44/12. So again, I can make that simpler, much simpler. Divide by 2, 6 gives me 22. 6, divide by 2 again, and I get 11/3. So I can get 9 out of there, so I get 3 2/3. 3 2/3 is my answer. All right. So any questions? So just to review before we go over our questions. Any questions? No? So remember, when we multiply fractions, you take top to top, multiply, bottom multiplies by bottom. When we do division, we flip them around and it becomes a multiplication. And you do top to top, bottom to bottom. All right. So I'm going to write a few questions on the board for you to do. I'm right here. So if I do 3/4 times 1/2, 8/9 divided by 5/6, 2 2/3 times 7/8, and we're going to do the same here. We're going to go, actually I'm going to go 7/8 divided by 2 2/3. All right, so you guys can work on those. All right, so if you have any questions. All right, great job. We reviewed all these. Great. So, one thing is that we often, when we do math, I always hear, how does this apply? Well, this applies as carpenters. We actually use this all the time because when I am marking out a 2x4, when I'm marking a 2x4 on edge, when I'm marking out studs, when I have my 16 center, how far do I go this way? How far do I go that way? Back. 3/4 of an inch. So 3/4, 3/4. How thick's a 2x4? 1.5 inches. 1.5 inches. And I want to divide into 2 sections. So I'm going to divide that by 2. So 2 over 1. So 2. So this becomes 3/4. Flip this over. And times 1/2. Oh, not 3/4. 3/2. 3/2. And so I'm going to get 3/4. So I know that I go 3/4 back, 3/4 forward. When we're laying out walls and we have to the center, I have a 2x4 wall, 3.5. I need to know how much back and forth. I know that it's 1 3/4, 1 3/4. 2x6, same thing. 2 1/4, or 2 3/4, 2 3/4. So we are using this all the time when we're laying out walls, when we're doing math and all that, because we all love doing imperial. Nobody loves building in metric. So until that changes, we're building in imperial, which always has fractions. So we're always multiplying and dividing fractions as we're doing carpentry. All right, thanks a lot.